So today we're still doing notes for homework number 8, and homework 8 is due on Tuesday. November 2nd. The week after that, there's no homework. We'll be doing review and taking a test. Okay. For this homework, it's kind of two parts. The first part is inequalities. The next part is absolute values. And at the very end, there are inequalities with absolute values. Okay. Also, so today we're going over absolute values. I'm going to stick with how the book explains it, which is translating what the absolute value means. But maybe later during review week, I can show you maybe like a trick to help know that you've set up the right equations, but I want us to practice using the definition first. Okay. The absolute value of x is denoted as absolute value bars around x. That's my absolute value of x, whatever's inside. And it is the distance of that value inside x. And then the distance that x is from 0, the origin. So it's always a distance from the origin when you're thinking about an absolute value. We're going to stick with just one variable. Which means we only need one number line and our origin is at the number 0, but you could be in 2D and you can be a distance from the origin of 0, 0, or in other spaces and other dimensions. You're still looking at a distance from the value in absolute value bars to the origin, to the 0. Okay, let's look at the absolute value of 5. Let me put is. Absolute value of 5 is the distance between 5 and 0. Okay, let's draw the number line for whatever real number. Let's go here with 0 and over to positive 5. So how far is positive 5 from 0? It's 5 units away. 1, 2, 3, 4. So the absolute value of 5 is equal to 5. let's do the absolute value of -4. This is the distance between -4 and 0. So we've got our number line. And here's 0. And we're going to -4. How far is -4 from 0? It's 1, 2, 3, 4 spaces away. Oh, okay. So the absolute value of -4 is equal to 4. This time, we're going to look at the absolute value of x is equal to, let's do 6. Okay, this means start here. Absolute value is the distance between whatever's inside x and the origin. So the distance between x and 0 is 6. So on a number line, we're going to start with 0. X is a distance of 6 spaces away from 0. So we're going to go 6 spaces this way, and we're going to go 6 spaces that way. To the right, you're going over to +6. And then to the left, -6. So you're starting at 0, and x is going to be a distance of 6 spaces, let's say, to the left. So x can equal -6. Or you go over to the right 6 spaces, 1, 2, 3, 4, 5, 6, and you land at +6. So there are 2 solutions, this one or that one. And then maybe a way to graph that is to just put a solid dot only on that part and don't shade anything else. Like that part and that part. And you're going to take away the top part. Next. So you're usually, most likely, going to be setting up two equations of absolute values. In general, absolute value of A equal to B implies that, or is equivalent to, A is equal to B, or A is equal to negative B. Okay, we want to solve the absolute value of 2x minus 1 equal to 7. And I'll put some steps down in a moment, but the first step is to isolate the absolute value bars, which you have that already. Absolute value bars are on one side of the equation. Everything else is on the other side of the equal sign. Now that those absolute value bars are by themselves, we're going to set up two equations. Take what's inside the bars, put it equal to positive 7 and equal to negative 7. So there's a 2x minus 1 equal to 7, or 2x minus 1 is negative 7. And then you solve each one separately and you get two solutions. Over here, we add 1 to both sides. We have 2x equal to 8. And then divide both sides by 2. And that is an x equal to 4. Okay, over here, add 1 to both sides. 2x is equal to negative 6. We'll take that and divide both sides by 2. X is equal to negative 3. Okay, we want to solve the absolute value of 4x minus 1 plus 3, and that's equal to 8. Okay, we need to have the absolute value bars isolated. So let's just put note. And after the absolute value bars are on one side of the equation, you can translate what they say. Okay, so it's kind of easy. We just take this 3 and just subtract a 3 from each side, and then the absolute value bars are going to be isolated. So we're subtracting 3 from both sides. Over here, you keep this absolute value of the 4x minus 1. And this side is 5. So we're going to set up the equations, but before we do, we're reading this as the distance between 4x and negative 1, between that number and 0, is 5 units. So this is 5 units away from 0. So that number is either positive 5 or negative 5. If you're doing this, if you are taking notes, I'd leave some space to solve that part because I'm going to set up the other equation as well, and we'll work on both of them separately. So that number is either positive 5 or it's negative 5. Okay, back over here. With this equation, we can add 1 to both sides. Then 4x is equal to 6. Divide both sides by 4. X would be 6 over 4. And those both have a factor of 2, so you get a 3 halves. Okay, it looks okay. 3 halves is one of my solutions. Let me go find the other solution. Each side. And then 4x is equal to negative 4. Divide both sides by 4. That's x equal to negative 1. Okay, so next is to talk about how to graph inequalities that have absolute values in them. And we're going over steps. The first step is the same for the problems we've been doing. You always start by isolating absolute value bars. So again, First step is get the absolute value bars on one side of your equal sign. Okay, and okay, one sec, I'll be right back. So hopefully I was able to just fix the light problem. It shouldn't flicker. Okay, so you get your absolute value bars. And this is sort of new to me, where the next step is to translate what it means. So I was kind of taught a trick, and I might show you the trick later, but I do think it's more clear to do it the way this book does. We translate the absolute value sign. It may take some practice, or you can ask me for help. For both. Translate. Actually, it's going to have more than just an absolute value, so translate the whole expression. Okay, next, we will use the translation to sketch a graph. Okay, and after that, we're going to use that sketch to create, I think, let me see. It's going to be use the graph to well, I'm just thinking because some problems require a little bit more work, but we'll just do that work when we get there. Overall, we're using this graph to find the solutions, either as a algebraic statement, a new graph, a drawing, or as a set. Okay, so you're either going to write, I'm going to do all of these today for practice. You're going to write a set, and we write our sets in interval notation. Or you can write an algebraic statement. Or if you need to, you can draw a graph, because it might not be the same exact graph that you use to start to solve the problem. we want to start with the absolute value of x is less than, I'm going to stick with less than 5. Oops. Absolute value of x is less than. Okay, for isolating the absolute value bars, it's already done. Those bars are on one side, got everything on the other side. Part 2 is translate what this says. This part says the distance between x and 0. Then this is less than 5. So I've already translated this piece. Now we're moving on to this symbol, less than. And then 5 units. We're going to use what that says to sketch a graph. Definitely going to want to place 0 and then go a distance from 0. The distance between x and 0 is less than 5 units. So we can go 5 units to the right, but not actually include 5. Very, very close, but don't include. Or the distance between x and 0 is 5 units this way, towards -5. So x can go from 0 over 5 units this way, or from 0 to 5 units that way, but not actually a full 5 units. So it's empty here and we shade in between. Okay, now we're going to use this graph to write down where the solutions are. Let's I'm going to first write it as different pieces, but then we can write the pieces together. So x needs to be greater than -5. And at the same time, x needs to be less than 5. So this can be written as x is between -5 and positive. -5 is less than x, which is also less than. So that would, this right here would be an algebraic statement. So that's an answer, a way to answer. Turns out that this graph is also the correct graph. So this is a representation of the solution set. The last one is to write the solutions in interval notation. Okay. It goes from -5 over to +5, and it doesn't include either end. So you have a parenthesis and -5, the smaller number, over to the larger number, +5. And it's also not included in this set, so it's a soft parenthesis. This time it's going to be x greater than or equal to 4. Absolute value of x. First, you'd want the absolute values isolated, which they are. You've got your absolute value all by itself. Then we translate what this says. Absolute value of x is the distance between x and 0. Okay, we've gotten that part. And now this symbol is greater than or equal to. For units. So next we want to draw a graph of what's going on right here. So you've got a number line and definitely want to mark 0. X can go 4 units. X needs to be 4 units this way and past. It needs to be greater than 4 units to the right and more than 4 units away on the left. So we'll go over 4 units to the right. Oh, it's greater than or equal to. So you can include the space where you're 4 units away and then past. For x and 0, the distance between x and 0 is greater than 4 units this way. So you can go here, be equal to that number, and go past or towards negative infinity. So I do have 2 different equations, and the first one is x is less than or equal to negative 4. And it's here, or it's over there. So, or x is greater than or equal to 4. Turns out this would be the correct graph. This is our algebraic statement. And then the set in interval notation needs to have a union of this set with that set. So after we put the set together, I'll go over the union of sets. So let's start with the smaller set. Goes from negative infinity, which is not included, over to negative 4, which is included with a square bracket. This is a union symbol. It means you're in that set or that set. The other set starts at 4 and does include 4. Goes to positive infinity, which also is not included. I have two sets, A and B. A union B is the set of elements from A or B. Okay, try A union B, we take A, the big U for union, and then B. And this union symbol is curved on both sides. It's not actually a big U, it's just a swoop. Okay, A union B. It's an A or B. One, the other, or both. Wait, hang on. It depends on the set though. In that set, it has to be one side or the other side. But depending on what sets you're looking at, or means you're in one set or the other set, or possibly both sets. Okay, let's go back to this. So absolute value of 2x minus 5 less than or equal to 3. Okay, so I suggest, well, since the absolute value is isolated, I will go into translating what this says. So this says the distance between this value, 2x minus 5, and 0 is less than or equal to 3. Okay, now we're going to use that to sketch a graph. Place 0 first. Okay, C. So that value is a distance away from 0 that is less than or equal to 3. So we're going to go a distance of 3 spaces to the right and 3 spaces to the left. And your value is less than or equal to 3 units from 0. So you can go 3 units over, include that number, and be from 0 up to 3. Or let's see, the distance between 2x minus 5 and 0. The value is the distance less than or equal to 3 spaces this way. So you can go here and go less than 3 spaces towards 0. Okay, and it's in that place that you don't just have x values, you have values of 2x minus 5 in the shaded spot. So we need to set up some more work. First, I'm gonna go see if I can fix this light issue, and then I'll come back here. Okay, that made it way worse. May need to use these slides for now. So I think we can see everything. Sorry about the glare. Oh, cool. Oh no. Okay. I'm gonna go get a lamp and then we're gonna keep on doing this. And then I'll try to fix the light over the weekend. But thank you guys. Thanks for working with me. See, this looks okay. Let's get this a little different. Okay, one more try. It's probably as good as it's gonna get. All right, so back to this. Our number, whatever this value is between -3 and +3. Which we're gonna write like this. -3 is less than or equal to 2x minus 5, which is less than or equal to 3. I'm really glad that we've gotten a problem like this because I didn't get to go over this example on Tuesday. When there's 3 different pieces, you solve for x by doing your operations to all parts of the problem. So if I subtract 5 from the middle, I have to subtract 5 from this end and 5 from that end. Cool. On this side, it's -8. Less than or equal to 2x. Less than or equal to -2. We're going to take this and divide all 3 parts by 2. So much shadow. Okay, this is -4, less than or equal to x, which is less than or equal to -1. So that would be one way to answer as an algebraic statement. Or you can draw a graph. So the graph of solutions is going to be between -4 and +1, including both ends. So this graph isn't the solution. This is just like scratch work. This part would be how you can answer the problem. And the last way to answer it is as a set. In interval notation, you have your smaller number over to your larger number. Okay. -4 to +1, and you can include both of the ends with the square bracket. Ooh, let me make sure. That's good. That's good. I think that I made a mistake. I want to go back through this problem. So just maybe do it a little quicker, but I have a feeling that something went wrong. So let's just check again. You may be just rereading your notes, but I don't have this in my notes. Okay, we had a problem that was absolute value 2x minus 5 less than or equal to 3. We translated it, and then we had the distance between 2x minus 5 and 3, or is less than or equal to 3. So we put a -3 less than or equal to 2x minus 5 less than or equal to 3. Okay, no, we did the right thing. I just made a mistake in my packet. Oh, no. Here it is. So that part's correct, but it's when we do the next step, we want to add 5. I think I subtracted 5 last time. I don't know, something went off from what I have written down. Let's do this. This would add up to 2. And this side is 8. And then we divide through by 2. be 1 less than or equal to x less than or equal to 4. So the graph should have gone from 1 to 4. Including both sides. Which means the solution set was actually +1 over to +4, including both sides. Okay, let's see how much time this. I feel like we can do another example or two. So we're going to try to solve the absolute value of 2x plus 1 plus 4 greater than or equal to 7. The light starts to flicker, then I'll go back to the other lights, but let's see if this will stay. Okay, before translating, we need to isolate this absolute value bar. So we'll subtract 4 from both sides. Okay, next, translate. Absolute value is the distance of this number from 0. And that will be greater than or equal to 3. So all of that comes from the absolute value bar. Absolute value is the distance between this value and 0. Now we're at greater than or equal to. And then here, 3 units. So we're sketching what's going on. We start at the origin 0. And this value, 2x plus 1, is more than 3 units from 0, and including. So we can go over 3 units, include that number, and go past. We can go back 3 units, include that number, and go further away from 0. So it's a distance of more than 3 units from 0 to the left or to the right. And in those shaded places, it's the values of 2x plus 1 on either side. All right, so I need two separate inequalities. Either 2x plus 1 is less than or equal to -3, just that piece there. Or, and we'll have to solve this, and then on the separate board, we'll solve the other side. Okay. Or we're over in this set, where you have 2x plus 1 greater than or equal to 3. And we will solve each of these. Here, let's go ahead and subtract 1 from each side. 2x is greater than or equal to 2. Divide both sides by 2. X would be greater than or equal to. Okay. Back here, we can subtract 1 from each side. 2x is less than or equal to -4. Okay, I have a feeling maybe the light bulb's just going out. But anyway, we'll finish this problem and then I think that'll be enough. So we're dividing both sides by 2. X is less than or equal to -2. So if we were going to write it algebraically, we want to put both parts together. It doesn't matter which part is first, really. You could put the x less than or equal to -2, or x is greater than or equal to 1. We could sketch a graph of that. 0, let's go back to -0, +1. We could get -2 or less than or equal to. +1 and greater than or equal to. And the set of solutions. Is two sets unioned together. And start at the very, very smallest value, -infinity. Go over to -2 and include it with a hard bracket. Union the set with the one that starts at 1 and includes 1. It goes over to +infinity. Okay, actually, we do have time to do one more example. I know I'm at least a little frustrated with the lights, but I can get through it for just a little longer. So let's just try one more for practice, and then we'll go. Okay, we're going to solve the absolute value of -4x plus 2. Less than 6. Seems okay. So first step's taken care of. The absolute value bars are on one side of the inequality. Then I'm going to translate what the absolute value means. It's the distance between 0 and that number. And then we go here to less than, and then 6 units. So again, all of this part comes from the absolute value of our symbol. So the absolute value is the distance between the negative 4x plus 2 and 0. And copying this symbol down, less than. And at the end, we've got a 6. So we sketch what that means. We're going to start at 0 and go less than 6 units away, either less than 6 units to the right or less than 6 units to the left. So we'll go over to 6 and not actually reach 6. We'll go to negative 6. Negative 6. And that's a place where you have values of negative 4x plus 2. So the way we'll set this up is to take this and put it between negative 6 and 6. So negative 6 is less than negative 4x plus 2, which needs to be less than positive 6. All right, we're going to subtract 2 here and here and here. It's negative 8. Less than negative 4, which is less than 4. Oh, x. Okay, what I have will need to be divided through by the negative 4. When you divide by a negative number, you have to flip the sign. And this time you have to flip both signs. So divide by negative 4 in all 3 spots. Flip both signs. And here's a positive 2. This is 1x. And this is negative 1. Okay, and then I'm just going to pick up this statement, keep it how it is, but flip it around. It's just easier for me to read that way. You don't have to do this if you don't want to, but it helps me. So negative 1 has a pointy side. It opens towards x. That symbol points to x and opens to 2. So x is between negative 1 and positive 2. Sketch a graph. Okay, do not actually reach negative 1, so it's open. And don't include positive 2, but have all numbers in between. So the solution set goes from negative 1 to 2. And it has a parenthesis on each side. I feel like that's at least enough for you to do the homework, but if you have any questions, let me know. And we're gonna call it good for today. Have a nice weekend. And there's no quiz to do this week. We might do one next week, but we're coming close to exam 2, so just keep up with the homework, I guess. Okay, thanks everybody.